correct? So in the previous class, we have discussed about the reference bus RB1 and RB2, and we have seen about guard time in the TDMA frame. Okay, so this guard time helps you in the TDMA frame to avoid the overlap of the information near the input of the transponder at the earth station, because this frame is being designed near the earth station and that is sent to the satellite. In the same way, when the satellite has to send the data to the earth station in the reverse, there also the frame will be designed in TDMA form, and that will be sent from the satellite to the earth station in the reverse. So the same thing will happen on the other side also, but we are discussing now only the TDMA in terms of transferring from the earth station to the satellite. Okay, so these two things we have seen, the reference bus 1 and 2 and the guard time. Next, we are going to discuss this in terms of the next point. Okay, seventh point. The reference bus RB1 and RB2 are used in the TDMA network that does the operation in terms of automatic switching, operation, automatic switching. Okay, does the operation in terms of automatic switching for the data to analyze. Okay, so in the reference bus RB1 and RB2 that we have, the TDMA network, those will be operated in terms of having this one, where these will do the automatic operation of switching operation to make the move of the data in your network. So it will move the data in the network in such a way that to know from which earth station we are getting the data in terms of frame. That can be understood for us. And also it helps you to synchronize the TDMA frame with the earth station and the satellite. Okay, reference burst helps to synchronize the earth station with satellite. Okay. It helps you to synchronize the earth station with the satellite in this manner. Next, we are going to see the traffic burst. Next, we are going to discuss about traffic burst in the TDMA frame. Okay, we have seen about reference burst. Okay, guard time. Now we are going to discuss about the traffic burst, the most important traffic burst. You can see that in the TDMA frame we have a traffic burst that we are going to discuss now. Okay, traffic burst in TDMA frame. So the traffic burst in the TDMA frame, okay, we'll write in terms of points. The traffic burst carry information from the Earth station. Information from the Earth station. Okay. So this is original data. Okay. This is your original data. Don't forget that. Original data is nothing but original, that is your original information which you want to send. Okay. So each station axis, as in the discussion we told that each Earth station has a transponder, and that transponder entire bandwidth is utilized to synchronize with the satellite and send the frame to the satellite. So now each Earth station accessing transponder that transmit one or two frames traffic burst, BURST. Okay, one or two frames of traffic burst in the TDMA frame. What is this indication is, in the TDMA frame we can have more than one traffic burst frames. Okay, one or two traffic burst frames that we are saying. No, we can have more than one, or minimum one, or more than one. We can have two or n number of traffic burst frames we can have. That is the thing he wants to say here. So the Earth station accessing the transponder that will transmit one or two frames of traffic burst in the TDMA frame. Okay. So another point here is the traffic burst can have the frames anywhere in the TDMA frame structure. Okay, traffic burst can have the frames. Okay, it is not proper. The traffic burst frames. This is better. The traffic burst frames can be present anywhere in the TDMA frame. Don't forget that. Okay. So in the figure itself, it is shown clearly that we are having the traffic burst here. One. This is one frame. One. And this is two. So you can have this traffic burst anywhere in the frame. Okay. It doesn't mean that you should have only one traffic burst. You can have n number of traffic bursts in the TDMA frame, but it doesn't mean that all the traffic burst frames should be present one after another. It is not like that. You can have the traffic burst frames somewhere else. Okay, you can have anywhere in the frame. So like that, you'll be having the structure. Okay, like this TDMA frame structure is designed. TDMA frame structure is designed. So we have discussed now about the traffic burst in the TDMA frame. So we have seen previously about the reference burst. Okay, we have discussed about the reference burst. We have discussed about the traffic burst. We have discussed about the guard time. So this is the internal things that are present in the TDMA frame. So we will go in depth about the data that is present in each and every burst. Okay. Next, we'll go to discuss. Okay. Now we will see in-depth data that is present in the frame structure. In-depth data in the frame structure of different bursts that we discussed now. Okay. We will see in-depth data that is present in the frame structure of the different bursts that we have discussed now. In this, we will now see about reference burst frame structure. Okay, so now we are going to start with the internal structure of the reference burst now. So what is the intention? We have seen the TDMA frame. From the TDMA frame, we have studied what are the things that are present in that. In that, now we are going to study in depth about each burst and what is the information that is present in each burst. That we are going to start now. Okay, which we are going to start now. So internal structure of internal structure of reference burst. First one that we are going to study is about internal structure of reference burst. How you have. So we will write about this one. Okay. So just I will show you the internal structure of the reference burst now. So this is the reference burst internal structure. You can see clearly. Okay. Internal structure of reference burst. Right. And we will have the next one. Okay. We will discuss the next one also. Before that, we will see what are these terms called as. We will see about these terms. What are these terms called in the reference burst that we are going to see now. Okay. So we'll start with that. Okay. The elements that are present in the reference burst. First one is carrier and bit timing recovery. That is called as CBTR. Carrier and bit timing recovery. Next one is called as unique word, which is known as UW. Third one is called as teletype. Okay. Teletype, that is TTY. Fourth one will keep as voice order wire. Okay, voice order wire. VOW. We have written that now VOW. So that's why voice order wire that we have. Okay, VOW. Next, we can have service channel. The next one is control and delay channel. Right. So these are the elements that are present in the internal structure of the reference burst that we are discussing now. We'll discuss each and every point in detail. What is meant by CBTR, unique word, teletype, voice order wire, service channel, and control and delay channel. ఇవన్నీ మనము separate గా చదువుదాం. Okay, we'll see. We'll discuss each and every point now only, but I'm showing you the internal structure of the reference burst. Don't forget that. Okay, so we are seeing the internal structure of reference burst, that is of TDMA frame. Don't forget. From which frame we got this one is from the TDMA frame. We have gone into the internal structure of the reference burst. So like that we are studying this point. Okay. Now we start with the first one, that is carrier and bit timing recovery. That is CBTR. Okay. We're going to start with this one. Carrier and bit timing recovery. So that is the first we are going to start with. So this CBTR pattern, so this is some information, no? So that CBTR pattern provides information of carrier and timing recovery circuits, okay, of the earth station. Okay, of the earth station. What does it mean? This CBTR pattern provides the information of the carrier and timing recovery circuits of the earth station. Okay, at the demodulator. You're getting a point called as demodulator now. What does it mean? So the CBTR is nothing but it will provide the information of the carrier and timing recovery circuits of the earth station at the demodulator. What does it mean is, near the earth station you will have a demodulator device. Okay, you will have a demodulator device. You have studied in your communications demodulation, no? So the same process, demodulator. So the demodulator will be present with a carrier and timing recovery circuit. You will have a carrier. What does the carrier says is, carrier is nothing but to see high frequency signal. Okay, and to see high frequency signal and recovery circuit is to regenerate the information. Okay, and the recovery circuits to regenerate the information. Okay, that is the thing. The carrier is to see the high frequency signals that are present in the data. Okay, high frequency signal present in the data, and recovery circuit is to regenerate the information. So because we use the demodulator, no, what is the intention here? You will receive the signals from the satellite to the earth station also, no? We will receive the signals from the satellite to the earth station. So definitely you have to do the demodulation process to retrieve the information. So that's why we are having a demodulator also near the earth station. So that helps you to carry the high frequency signals that are present in this one, and it will try to provide the information that is present. Okay. So that is the thing what happens here. It is trying to provide the information in such a way that to make the use of this one to recover the data. That is the thing what happens. Okay. Third point, the length of data sequence bits depends on C by N ratio, carrier to noise ratio at the input of demodulator. Don't forget this point. So as we are saying that we are getting the information near to the demodulator now, you have the sequence of data sequence of length of bits. So these bits that you have obtained depends upon the C by N calculation that you have done before getting the data to the demodulator. Please understand clearly. The data that is coming to the demodulator is nothing but before itself you are calculating C by N ratio. When you calculate carrier to noise ratio, it makes you to understand what is the sequence of length of data that you got in terms of bits. So those bits are given to the demodulator as an input, and those bits that are received in the demodulator, that is consisting of with a carrier and timing circuit, recovery circuit. So those bits what are received will be understood by the carrier and timing recovery circuits, and it will remove the high frequency carriers, and it will recover the original data with the help of the circuit. Okay, so that is the thing what happens here, right? So this is another point about CBTR. Okay, next we are going to discuss the CBTR only. The next point is that it makes you to understand the next one. Okay, fourth point, right? So we will take an example just to understand. Okay, example is, for example, for a satellite of Intel Sat B, okay, has a option to transmit and receive the data in, sorry, in terms of 120 megabits per second. Okay. For example, for Intelsat V5, okay, we have taken the satellite Intelsat V5, and that helps you to get the receive the data in terms of 120 bits per second. Okay, it will generate 48 symbols pattern, 48 symbol pattern for carrier recovery, and 128 symbol pattern for timing recovery. Okay. So what does it indicate here is that it is generating the pattern which is nothing but 48 symbols. It is generating a pattern 128 symbols. Okay. pattern, 128 symbol pattern for timing recovery. So these all are generated in terms of the satellite. Okay, these all are generated in terms of near the satellite of the transponder of demodulator, and also near the earth station also will have the same thing. Okay, I'll write in terms of pointer. These symbols generation in terms of both earth station and satellite demodulators and transponders. Okay. So we have taken an example. You can see that in Intelsat 5, what is the indication here is that 48 symbol pattern is nothing but 48 data bits are generated for carrier recovery, and 128 bits are generated for timing recovery. So carrier bits are nothing but additional high frequency bits. So those are 48 bits, and 128 bits are nothing but timing recovery, which is nothing but recovery timing. So in recovery timing is nothing but how much time it is taken to recover the original data by removing the high frequency signal. How much time it is taking to recover the original data by removing the high frequency signal. So how many bits it is generating? 128 symbol pattern. So that is the thing. So this operation will take place both near the earth station and also the satellite of the demodulators and the transponders that are present here. Okay, don't forget that. So that is the thing it wants to explain here. Okay. Right. So this is the thing what happens in CBTR that we have. Okay. Next one. Unique word. Unique word. So next one is about your unique word. Just we'll see about unique word now. So before going, once again I'll discuss. We have discussed about CBTR now. Okay. We have discussed about CBTR now. So this is used for the information timing recovery circuits that are present in that. High frequency signals are being present in that are look after and recover the regenerating of the information takes place. Before doing that, we will see the length of the sequence what we are getting to the demodulator. So how we will be knowing that is with the help of carrier to noise ratio, which is calculated and given as an input to the demodulator. And this is being known by taking some example that we have set everything in Intelsat 5. Okay, Intelsat V by taking 48 symbols as the timing and 128 symbols as the timing recovery, 48 symbols as carrier recovery. So the carrier symbols are 48 and 128 symbols are the timing recovery. So both the symbols generation takes place in the earth station and the satellite. So this we have seen. Next we are going to start with the unique word. Unique word. What is meant by this unique word? This this unique word sequence in the reference burst provides the received frame timing and allows the earth station to locate the position of traffic burst in the frame. Wow. It is very easy. The sentence written is very long, you may think, but it is very easy. This unique word is nothing but that is present in the reference burst. So this receives the frame timing, okay, it allows the earth station to locate the position of the traffic burst in the frame. Okay. So what does it mean? The unique word sequence which is present in the reference burst provide the receiving frame timing. Okay. Frame. I'll keep this one as highlighting as frame timing. It allows the earth station to locate the position of the traffic burst in the frame. So what this one is doing? It is doing about locating the position of the traffic burst. So two things are happening in the unique word. Two things are nothing but the unique word sequence in the reference burst provides the frame timing. Receiving frame timing. Where how it is receiving frame timing? When data sent from Earth station, okay, Earth station to satellite. This is most important. Then it will identify in terms of frame timing. It allows the Earth station to locate the position of the traffic burst in the frame. This is when data sent from satellite to Earth station. Okay. Two things are happening in the unique word. Don't forget that. Right. So this is about the unique word. Okay. So the unique word is providing you the two things that receiving the frame timing when the data is sent from the earth station to satellite and allow the earth station to locate the traffic burst where it is present in the frame when it is sending the data from satellite to the earth station. So that is the thing what happening. And also another point in the unique word is the traffic burst marks the beginning of the traffic burst and provides the information to the earth station it is intended. So the second point is that the unique word, okay, UW is nothing but unique word. Me mali doubt avach. Sir, edo आपने जे partner रहा होगा. Something is saying new. The unique word is a sequence of ones and zeros. Ones and zeros selected to exhibit selected to exhibit good correlation properties to enhance detection. So what the thing happening here is the unique word ones and zeros is the representation of the data and that is also shown to enhance the detection process. So that makes it to identify the ones and zeros by differentiating by making the frame to have ones and zeros that apply for the frame timing when the data sent from the earth station to satellite and apply in terms of ones and zeros when the data is sent in terms of satellite to the earth station to locate the traffic burst where it is present in the frame. In the frame where you have the traffic burst to identify that is stored in the unique word. That value is stored in the unique word to identify the traffic burst where it is present in the TDMA frame. That is the thing. Okay. So this is about the unique word that we have. Next, we are going to discuss now about the next one, right? That is teletype and voice order Y. Both the things will study simultaneously. TTY and VOW. Teletype and voice order Y. So both the things we are going to discuss now. So what is meant by these two? TTY and voice order type carries the instructions to and fro. Just it is a basic point only. TTY and VOW carry the information to and fro earth stations. Okay. Carry the information to and fro earth stations. The symbol pattern is 8 symbols. TTY and voice order Y carries the information to and fro earth stations. Carry the information between to and fro earth stations. Okay, between to and fro earth stations, and the symbol pattern is 8 symbols we have. And also another thing, the unique word has 24 symbols pattern. Okay, the unique word has 24 symbol pattern, which has been shown, right? So these are the things about the internal structure of reference burst. So what are the things we have discussed now? We have discussed about unique word. We have discussed about teletype. We have discussed about voice order Y. So next we are going to discuss about service channel. Okay. Next we are going to discuss about service channel. What is meant by service channel? So when you go for this service channel, the service channel the service channel of the reference burst carries management instructions. Wow, there is a new meaning here. Now we are getting, that is management instructions. The management instructions. What is management instructions then? So management instructions are nothing but, this makes you to understand clearly. Now we'll be starting with, okay, the service channel of the reference bus carries the management instructions. So what are the management instructions? The instructions are such as first time plan, which gives coordination of traffic between earth stations. Okay, it gives the coordination between the traffic burst between the earth stations. What is the indication here? The instructions are such as the burst plan. How much is the burst that you are designing, and that should be coordinated with the traffic between the earth stations. Okay, if this has been providing the traffic between the earth stations, you can have the data to be sent with the synchronization with the earth station and the satellite. That is the intention of this point. The intention of this point is nothing but we want to synchronize the earth station with the satellite now. So when I want to synchronize the earth station with the satellite, I should have a synchronization time plan of the burst coordination between the earth stations. Okay, because multiple earth stations are there. We have discussed it in the class only. We are saying here we have multiple earth stations now, 1, 2, 3. So when you are having these multiple earth stations, there should be a synchronization and coordination between the multiple earth stations, which you are seeing here in the figure itself. So when you have the synchronization between the multiple earth stations, then we can send the data to the satellite with the coordination. So that is the important one here. So that is been looking after in the service channel. And the third point here is that it looks after the position, length, source, and destination. Okay, earth stations in the TDMA frame. What it is doing here in the service channel, it look after what is its position and how much is the sequence of length. It will also look after from which source earth station you are getting and to which destination earth station you want to send. These all things are present in your service channel, okay, of the bits that are there in the TDMA frame. Okay. It helps you to understand this. That is the thing he wants to say here. Right? Look after the position, length, source, and destination of the earth stations in the TDMA frame that we are looking after. Okay. Next point. Next point here is that it looks after the channel that monitoring and control the information of the traffic stations. It looks about the traffic control information of each and every station. It looks about the traffic control information of each and every station. So that is the thing about the service channel. Okay. So the service channel of the reference bus carries the management instructions. So management instructions are nothing but the instructions that are being given by us to the earth station how to work with the data. The service channel of the reference bus carries the management instructions. What is meant by the management instructions are nothing but the management instructions that are given by the provider to the earth station. So those instructions are the burst time plan to see the coordination between the multiple earth stations, to coordinate and send the frame to the satellite. And also look after what is the position and the length and the source and the destination. The source is nothing but what is the source of the data and what is the destination of the station that it has to reach. So this is about the service channel. delay channel. The control and the delay channel. So when you go for this control and the delay channel, it acquires this looks about the data acquisition and synchronization. Okay, looks after about the data acquisition and synchronization with Earth station. Okay, it looks about the data acquisition and the synchronization with the Earth station, and it calculates and enable the adjustment of delay in the data transfer from Earth station to satellite and vice versa. Calculates the enabling the adjustment of the delay in the data transfer from the Earth station to the satellite and vice versa. Okay. It also looks after about the primary and secondary reference burst information to be stored. Okay, so this is the thing what it is looking after. It looks after about the things of these things in the control and delay channel. Okay, in the control and the delay channel, it is looking after about these things, that is the data acquisition and the synchronization with the Earth station. We have to synchronize and take the data, and also will try to enable in such a way that to adjust the delay to get reduced the data transfer from the Earth station to the satellite, and also look after about the primary and the secondary reference of the data that is present. So this is the thing about the internal structure of the frame. Okay, what we have discussed in the burst. Okay, internal structure of the reference burst in the TDMA frame. So this is the thing about this one that we have discussed for this. Next, we are going to discuss about internal structure of traffic burst, because in the frame structure we have discussed about reference burst here. Now we are discussing about the traffic burst. Okay, right. This is the next one. Internal structure of traffic burst. This is the structure of the traffic burst that you have. Okay, nothing but it is nothing but the combination of your data. Okay, combination of the reference burst with the it is combination of reference burst and traffic burst, because we will have the continuation of the same thing, and we will add traffic data at the end by removing control and delay channel. Okay, the only difference here is that we are removing the control and delay channel here, and we are adding the traffic burst at the end. So this traffic burst is nothing but original data. Okay. That is the thing. It is about the original data. The original data can be of any type of data you can have here. In the traffic burst, you can have any data like voice, video, okay, data bits, etc. Voice, video, data bits, etc. So all these bits are divided in terms of blocks. All the information is divided in terms of blocks. Okay. So this is the internal structure of the traffic burst. So this is about your TDMA frame, what we have discussed now. Okay, just we are once again I'm showing you. Okay, so we have discussed about this till here now. So we have seen about this names that we are having. Okay, reference bus. So traffic bus. Now we have discussed about the traffic bus and the traffic bus frame and what the data that is present. And we have seen the traffic bus, how it is operating. And next we have seen after the traffic burst about this internal structure of the reference burst. So the reference burst is consisting of 6 things internally, and we have discussed about CBTR to see the CBN ratio near the input of the demodulator and see that we get the data retrieved when it is coming from the satellite to the earth station. And also we have seen the unique word, and this Intel sat one of the example, and the unique word we have seen to see the frame timing when you're sending the data from the earth station to satellite, and traffic burst from the satellite to the earth station, and ones and zeros is the representation, and teletype and the voice order wire is nothing but to have the information transfer to and fro within the earth stations. And also service channel is nothing but by giving the management instructions to coordinate the multiple earth stations in such a way that they will synchronize and send one after another the frames simultaneously and understand and give a time slot, and they will be sent in that time slot all the frames to the satellite. And also it will look after about the position, length, and from which source of earth station you are getting and which destination earth station you want to send it. And also the control and delay channel is nothing but it looks after about the data acquisition and synchronization, and it will calculate the adjustment of delay if it is present in the data transfer and reduce the delay, and also look after about the primary and secondary references that you have. And this is your internal structure of the traffic burst, and this is nothing but it is the combination of the reference burst. Okay, and we are removing the control and delay channel and we are adding traffic burst there, and the traffic burst is nothing but the original data which is consisting of voice, video, and data bits, and these are divided in terms of blocks that we are having. So this is about TDMA frame structure. Okay, this is about TDMA frame structure. Okay, this is about the thing about TDMA frame structure, right?